All right, hello and welcome. It's MattyAtoms. We are live, and today we're going to get into some more exciting stuff. I just got to open up my script here. Sorry, I had to restart my computer. Do, 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 do. Do a quick sound check, make sure everything is looking good before we get started here. Pictures. All right, looking good. Quick sound check. Okay, cool. So, I had a lot of fun last week talking about these different comets, talking about 3i Atlas. I think you guys did too. So, I wanted to continue along with an update. So, we're back at it today with another live. And as the title implies, we're going to be looking at updates on humanity's most mysterious interstellar object, 3i Atlas, as well as briefly going over two of our new visitors, C2025 A6 Lemmon and C2025 R2 SWAN. And finally, what fun is all of this information if we can't put it to use? We're going to get into some universe sandbox simulations at the end, and we're going to beam the Earth with some asteroids. So, before we get into it, make sure to like, comment, and share with your intelligent friends. Let's go. So, first off, the mysterious interstellar object that everyone is calling an alien spaceship or a probe, 3i Atlas. As of right now, it's approaching a solar conjunction, so from our point of view, it's going to pass too close to the sun's glare for us to see for a while. So, like I said last week, we're in a bit of kind of a waiting period right now. But interestingly enough, it's expected to reach its perihelion, its closest approach to the sun, around October 29th, just in time for Halloween. It'll be about 1.4 AU, so between the orbits of Earth and Mars. Um, NASA and official sources say it will reappear after it passes behind the sun around early December, when Earth and viewing geometry allow line of sight again. What's odd though is that we should have just received some images from Mars, such as the MRO and some of um, the little drones that are down there. But the U.S. government shutdown appears as a large banner across their website, so saying no new images are available. So just to be clear, people are still working at these agencies. It's not as if the government, there's nobody working at these sites. So it is a little bit weird, and there are people out there kind of saying like, hey, what's going on? Why aren't we seeing these Mars images? I understand that there's a government shutdown, but what's the deal? We have the MRO. We should be starting to see some of these images. The data is there. The people are there to parse it. So, like I said, why don't we have it yet? Um, so as always, I'll give you the official reasons first, and then we can sort of speculate using our big giant galaxy brains here. So officially, many spacecraft operations do have ongoing essential staff who remain active even during partial agency shutdowns. So as you can see here, this article, it's caught everyone's attention, and even some speculating that the space agency has likely learned some astonishing details about the comet and is holding on to the information. However, Avi Loeb, a Harvard scientist, says this proves nothing. It shows humanity's stupidity, and I kind of tend to agree with this too. There are people working there, but there are probably some people that are maybe laid off or furloughed. You're probably running at a slower pace. Um, So like I said, that does matter that they're running at a lower capacity. And let's not act like motivation doesn't matter too, right? When government employees think that they might not be getting paid, or when anyone thinks that there's a chance that they're not going to be getting paid, their productivity and motivation are definitely going to plummet. So, NASA's official statement is that they've stopped updating some of their websites due to a lack of government funding. There's also a precedent for government agencies sanitizing, embargoing, or delaying information just before public release. This has happened many times in the past. It will continue to happen in the future. They want to be able to properly interpret the data, properly present it, and package the story before it comes out. It's also possible that they're waiting for cross correlation with the ESA and other agencies so that they can have one complete story and more settled data before going to the public with it. And I think that's important. So, but, the other side of the coin is, the people that are like, hey, where's this data? Why aren't we seeing it? What are you trying to hide? Are you trying to scrub out certain information? So let me know what you think in the comments below. So, I said, in my research, I was unable to really find an official statement from NASA. Just kind of, they just say that the government shut down and there are delays to everything. And they did have an article, though, kind of refuting claims of alien technology and cautioning people not to use the aliens of the gap theory when real data and evidence lacks, right? And so if you're familiar with the God of the Gaps theory, it's the same idea. Just because we can't prove or like figure out what something is, or just because it's odd and mysterious, doesn't necessarily mean it's aliens. Now, on the flip side of that, I don't think it should be completely ruled out either. But later on, in probably like December, once we get all of this data, I will be addressing some claims such as Michio Kaku's claim that 3i Atlas is far larger than original estimates, that it might be hollow, and that it's carrying, or other people's claims that it might be carrying other probes that are breaking off. So from this whole week of researching, I haven't really been able to find any reliable data that backs any of that up. So if you find any, please let me know down in the comments. But I'll likely address it all, like I said, more towards the end of the year in December, once NASA, ESA, other space agencies, and amateur photographers around the world have been able to combine their data and paint a full picture. So as of right now, it seems like it's a really weird interstellar comet. But like I said last week, we just simply don't know. We've only ever detected 3 interstellar objects ever in our solar system. So we don't know what their characteristics would be, and we've never detected or seen an alien craft. And technically, we don't even really know that aliens exist, so we don't know what an advanced alien craft would look like either. But some have suggested that alien probes would disguise themselves as comets to avoid detection, and they've also suggested that at the 5-degree angle that Atlas is coming in at, and the fact that it's kind of skimming by a few different important planets, it just seems like a nice trajectory that you would want to take if you're sending some sort of probe into another solar system to collect some data. So, what do you think? Big dumb rock or big smart probe? So let me know down below. It really will kind of inform how I continue to cover the topic. I'm curious what you guys think. So now let's get into these 2 new comets, Lemmon and SWAN. So get Lemmon back here first. And there have just been some really, really beautiful images of them. I got one in the background over here too. There you go. Just absolutely stunning. And you can see the tail and the trail here. Some of this is dust. The thinner stuff that you're seeing kind of breaking off is dust. And then the thicker streaks and the colors that you're seeing, that's ions. So C2025 A6 Lemmon and C2025 R2 SWAN. When I first heard about these 2 comets, it was, of course, from clickbaity extreme titles about alien swarms that are coming from 3i Atlas. I'm sure you guys have seen stuff like this, so let's just nip that in the bud right away, right? There's absolutely no credible evidence that Lemmon and SWAN are in any way related to 3i Atlas, that their trajectory is similar, and in fact, data points to them being long-term comets that have highly eccentric orbits, probably originating out in the Oort cloud, or somewhere like that. So just check out this stunning image though of Lemmon doing work here. You can see that ion tail, the dust tail, and sometimes the tail can actually get clipped by solar winds. And so we're getting time right now seeing these living active comets placing new elements around our solar system, making it breathe. These are beautiful, complex objects, and the more and more that I'm researching it, the more of a real respect that I'm gaining. Just check that out. Look at that tail. Imagine in the future we'll make some sort of outer space surfing. People will find a way to surf comets, I bet you. Alright, I got lost in that for a second there. So, Lemmon is currently at a magnitude of about 6.6, and by the way, lower is brighter when we're talking about magnitude here. So it's visible with binoculars. Its closest approach to Earth should be about zero point 0.6 AU on October 21st, 2025, so really similar timing. It was discovered in January 3rd, 2025 by the Mount Lemmon survey with two M's, by the way, which is kind of annoying. It has an estimated orbital period of around 1,350 years, and that's according to Live Science, Earth Sky, Universe Space Tech, a couple of other sources, and this is based on, modeling and estimates. Um, because it's brightening, moving through constellations, and it has a visible tail structure, this gives us a chance to really watch this comet in evolution, how gas jets, solar wind, and tail disconnections can change in real time. So, really just an awesome opportunity for us here. Um, so now let's talk about SWAN. So SWAN's orbital eccentricity is just below 1. It's like 0.99937. So that means we're pretty sure it's orbitally bound. There's a chance that it could, it could not be. Its estimated orbital period is about 22,554 years. And again, like I said, that's using models. On human time scales, we'll only get one pass at this, right? Because like I said, 22,000 years. It'll sweep through our solar system as close as about a half a AU. And its closest Earth approach should be around October 21st, where it'll only be about a quarter of an AU from the Earth. So pretty cool. And just to quickly go over eccentricity and velocity here, you might be wondering, like I was wondering, okay, so how is it that we know that Lemmon and SWAN How is it do we know that they're long period comets that came from the Oort cloud, and how do we know that they're not interstellar, right? And essentially, so let's go over this really quick. So we track the comet's position over many nights using distance estimations, changes in motion. With those points, astronomers solve for the orbital elements, the semi-major axis, which is A, the eccentricity, which is E, the inclination, which is I, the perihelion distance, which is Q, etc., right? And using these mathematical formulas, they will determine if E is below 1, which means it's elliptical and bound to the sun, like a long period comet. If E equals 1, it's parabolic. And if E is over 1, it's hyperbolic, like 3I Atlas. It's just launching through. It's not really an orbit per se. So in SWAN's case, the E value that they got was 0.99937, which is extremely elongated, but still below 1. So that means it should be going on basically like the most elongated orbit you could possibly have where you're still bound to the sun's gravity. For Lemmon, orbital estimates point to a period around 1,350 years, so that's clearly orbitally bound as well. And so just to do a quick velocity and energy check. So from this position and direction, then we can derive the velocity vector. So we compare that to the solar escape velocity at this distance, and if the kinetic energy is too high over the speed of the solar escape velocity, then we determine that it would be over an E value of 1. But these comets don't show that. Non-gravitational forces such as jets and outgassing can change the orbit quite a bit. So remember, that's why I said with a 0.99937, we're pretty sure it's orbitally bound, but you never know. Things can always happen along that long journey, right? And who knows what will happen when it melts, gets more outgassing, etc., right? But as new data comes in, the orbit is refined, and if it started looking hyperbolic but later settled to an E of less than 1, it affirms it's long period and not interstellar. Comets often behave erratic early, and fits can shift, but SWAN and Lemmon's orbits are holding as long period bound, at least as far as all the data that we have right now. And then just as a quick bonus, there's also C2025 Ki Atlas in the mix. So this is the third comet that was discovered this year that may or may not brighten. I don't think I pulled up an image of that one. But this one, it's not even very bright anyways right now, so it's not very interesting looking. But so this is where, when you got Lemmon, 3I Atlas, SWAN, and then now C2025 K1 all kind of happening in the same month, this is where you're getting these really kind of extreme media sources saying things like, there's 5 bright comets or a comet swarm all coming in, or even like an alien probe swarm. but they're not all grouped together. They're not all in the same inclination. They're not all in the same orbit. Um, so it's a wild comet season for sure, but I'm not confident enough to say that they're all natural either. But I'm not going to tell you they're aliens. So I'm just going to sit on the fence on this one. I'm going to construct a whole little platform just on top of the fence, and until we get more data, we don't really know what these things are, and hopefully we'll be able to get more data on Three Eye Atlas, and it's like Oumuamua, we still just have the mystery of it, and it'll just remain like that for quite a bit. So I don't know. Let me know what you think about these comets. Are their estimations of these orbits accurate, do you think? You know, are we able to easily tell if it's a long period comet or interstellar? Because that was my main question here. And it turns out we basically do it with math and modeling. I would think that we're probably pretty accurate within reasonable bounds. But let me know what you think down in the comments. And now it's time to smash some stuff. Just give me 1 second here to kind of switch everything over. All right, nice. So I was thinking today, since we were talking about comets and all of that stuff, that we could just smash some comets into Earth and see what's going on there. I actually kind of want to look up, so estimated sizes of Lemmon, SWAN, and Atlas. Let's see what I get for that. I'm going to see if they either have them in here or if we can do we'll find like a comet that's hopefully a similar size to Swan or Atlas or something like that. So should be pretty sweet. Let's check it out here. We'll lock onto the Earth. So, I also wanted to just show you guys this guy live real quick too, because I want to kind of show you these orbits, just to really show how kind of elongated they are. And I should have probably brought this up while I was talking about them, so I apologize for that. But so this is Lemmon. This is where Lemmon is right now, the direction that its tail is facing. This is where it's going to turn back around. Pretty close flyby with Mercury and Venus here. Not coming super close to Earth. And if you look when I keep zooming out, this is how large they think the orbit is compared to, these are Pluto and Neptune out here. All right, so that's Lemmon. Refresh this one. This is SWAN. Now this is the one with like the 22,000 year orbital period. Just go way out here. So again, 0.9997 or something. It could possibly be interstellar still, I would say, because I think scientists like to underestimate their possibility of being wrong. But that's just what I think. But either way, if it's orbitally bound, it's very extremely eccentric. It got thrown in here from the Oort cloud or something, or this is just its normal orbit. Totally wild to think about that journey that it has to take all the time. And then this is Three Eye Atlas. So like I said, this is a 6. This is an orbit, an E value of 6, right? It's almost straight. It's just getting its angle bent a little bit by the sun as it comes through. Right? Silly ads. Okay. Now that that's out of the way, let's bombard some stuff. Check out the chat. Silver Surfer. Nice. Yeah, sorry I wasn't reading the chat during that because I was kind of reading off my script, but let me know if you guys have any comments that you would like to hurtle into Earth. Let's see. They're probably not going to have them in here yet, I would think. Let's see. Three Eye Atlas has a diameter of about 5.6 kilometers. Let's see. Objects, galaxies, moons, planets, stars, all rings, black holes, galaxies. I know they have like random comets. Hold on. Oh, there we go. So let's see, 15.9 kilometers. So I'm looking for something about 5.6 kilometers, and that'll give us the size of 3I Atlas. Unknown, unknown. Diameter of about 5.6. So that's a radius of about 3.3. No, 2.8. Yep. Look for a radius of 2.8 kilometers. Oh, that's pretty close. Okay. We're going to crash this guy into the Earth. And we'll just kind of get an idea here then of what kind of damage it's going to do. Just to be curious. And by the way, actually, let me look this up. I just saw this. There was a very small asteroid. Sorry, I had to pull this up on my phone because I literally just saw this like a half hour before I came on. 2025 TF passed 265 to 270 miles from Earth above Antarctica. But it's really small, as estimated 1 to 3 meters in diameter. But I saw a really doom and gloom post about it, and it is true. And it's actually, according to most estimates, probably the third closest asteroid ever detected to fly by us. So 2025 TF, very interesting. Okay, now let's get into some crashing of stuff. So, like I said, this is going to be pretty similar. Like I said, we don't know the size of 3I Atlas anyways. So, but this is, I said, we think it has a maximum diameter of about 5.6 kilometers, which would be 3.8. So this is pretty similar. This is going to be a little bit smaller. We launch it over the ocean. All right. Make sure we're nice and slowed down. Yeah. See, that's pretty small. But let's see what kind of damage it does. Boom. That was kind of surprising. We got any tidal wave going on? Nothing really? I feel like there would be a tidal wave from that for sure. A tsunami. I don't know, Universe Sandbox. I don't know if you got that one completely right. We'll try one a little bit bigger. So this would be just slightly larger than 3I Atlas. I said that we think. I'm sure the estimates on the size of 3I Atlas are going to change for sure. So, definitely. Alright, so this is basically 3I Atlas, but more rock shaped. Boom! Yeah, that wouldn't be nice. Let's try it over the ocean now. Nice. Launch a couple of those things. So I don't know, something like this size, you think it would cause serious damage to society depending on where it hit, you know? Ooh, that was a big handful of them. But, you know, keep in mind that with today's society, you wouldn't need a comet to really take out mass swaths of land. Really, like, if the power grid went, I mean, you'd have mass panic everywhere, I think. If you get the power grid and satellites and stuff tripping out. Pew, pew. Let's see. Ooh, this one's way bigger. So now, let's see. R2 C25 R2 SWAN, the exact size is not specified, but it's reported to be dramatically brighter than 3I Atlas. So still being observed. So let's say this is SWAN, since we don't know the size of it anyways. Bum 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 bum. Nice. All right. We can keep going bigger and bigger here. But what do you guys think about these different comets? Do you think that they're interstellar? Do you think that they're orbitally bound? I said, do you think that our math is pretty accurate when it comes to trying to determine these orbital paths? And I guess the most important question, do you think it's natural or not? Ooh, let's try Neowise. So this one's pretty big. Sorry, Australia. You've been Neowised. Could you imagine having the ability to just like launch these? Like of alien civilization. That's another thing I thought of, you know, I was like, what if an alien civilization has learned to redirect comets, you know? That would be totally crazy. Wait, did I fix my screen yet? Okay, cool. Sorry, I was just kind of checking some of my setup over here, making sure that you guys can see everything right. Cool. Good stuff. I want to flip Earth upside down now. Just for fun. Whoop. We'll do kind of sideways too. Earth can be all kinds of messed up now. We're upside down. Been hit by several comets. I feel like life is still going on though because I didn't launch any super massive comets into it. Although, you know, the whole upside downification. Where is North America? Uh-oh. I might have lost North America, guys. Let's check this out real quick. I just want to get the lighting on here. There we go. I guess everything just kind of crunched together. I did just sort of flip the Earth upside down though, to be fair, so. That's Africa. Oh, here's North America. I was going the wrong way. It is crazy how far west North America is from South America. Most people think of South America as being really far south of us, which it is. But almost all of South America lies, or I should say to the east. It's to the east of Florida, which is pretty crazy. I was looking in a totally wrong spot. Alright. Pachow. Alright, so now we have kind of a sideways and upside down Earth. And we'll launch some more stuff into it. We're going to have a water world eventually. Boom, 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 boom. Just to see. I said the first couple comets that we launched into the Earth were trying to find about the size of Atlas and SWAN. But like I said, I guarantee you that the estimates on the size for 3i Atlas, SWAN, or at least 2025 R2 SWAN and 2025 Lemmon, they're going to change drastically over time. Alright, sorry Earth, we don't really want civilization anymore. This is going to be fun. Now it's just going to be a ring of fire. Just a machine gun. Yeah, what if aliens could actually harness and like knock comets and asteroids around and hit us? That'd be totally wild. Pew, 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 pew. Nice. I get a nice short out of this, I think. I'm gonna just let this rock. Nice. That's so weird. The YouTube studio thing. Definitely need a new computer soon, guys. Let me know what you think. Do you want to get hit by a comet? No, I'm just kidding. I definitely don't. You know, and what's crazy is like as our detection methods get better, we keep seeing more of these. So that's one thing that I would caution people with, right? Is just because we're like seeing a lot more objects now, it's quite plausible that our detection methods have just got so much better. You know, we have all of these arrays of telescopes now that are meant to simply just look for comets, to look for anything, NEOs that might be close to us and might pose any sort of risk to us, right? So, oh, and by the way, so I know I'm still on about this Pluto thing and Pluto getting demoted to a dwarf planet, but I think I might have found a real scientific way that we can either get Pluto back promoted to a planet or we can get Earth demoted to a dwarf planet. So, this is the idea, right? The third criteria for a planet, and the reason why they say that Pluto isn't a planet, is because it can't clear its orbital path of all the debris out there, right? However, there are so many near Earth objects that we're discovering now. Okay? Like, I just want to show you this real quick, okay? These are all the near Earth objects that are essentially um okay, this is a visual representation to give you an idea. Okay? These are all of the objects that come somewhat close to Earth. So we haven't cleared our orbit of any sort of debris field either. So by the logic that they demoted Pluto down to a dwarf planet, Earth should actually technically be demoted to a dwarf planet because that doesn't look like a cleared debris field to me. Okay, I might just be being a little facetious, but um, you know, it's a fight that I'm willing to take on. All right. I wonder how Earth is doing. We're upside down. We've been bombarded by a bunch of stuff. We're still relatively the same distance, going a little bit faster. Obviously, our rotation is weird, so our ice caps are going to change. Probably at some point, but we'll have to speed it up for that to happen. Let it rock out for a little bit. Key when you're fast forwarding in this, guys, lock onto the sun because otherwise it's going to spin around and get you all dizzy and stuff. So I'm just going to let them race a little bit. Let Earth do a couple laps around the sun here because I want to see if, because like I said, I flipped it upside down and we've bombarded it with tons and tons of comets larger than Atlas and Swan. So Earth is all kinds of messed up right now. So we've probably melted a lot of the polar caps with the comets, and then like I said, I flipped it upside down too, so it's now essentially spinning more sideways than it normally is. It kind of has like a Neptune-like orbit going on. So yeah. Alright, let's check this out real quick. Get up in there. See how Earth is looking now. So this is your new North America. North America. Alright, so the North Pole is basically the South Pole. So I did essentially just flip the poles. But it's a little bit skewed. So we're going to have a colder Australia. I don't know. I think Eurasia got really cold. Like up here. Europe and... I don't know. Actually, more or less the same, I guess. If it's upside down, it would just be, the opposite. I think we need more comets. I want to get this for a nice short, so let's find a bigger one. Scott Manley. Oh, Manley. Slow this on down, boss. Slowing her on down, boss. Pew. Bye-bye. Alright. I'm tired of you, Earth. You're getting Plutoed. It's the revenge of the Plutos. See, this is what happens when you just demote a planet. It will get its revenge. Bye-bye. All right. Well, I hope you guys had fun today. I hope you enjoyed talking about these different comets and interstellar objects. Aliens, maybe, probably not. But, like I said, let me know what you think about the orbits. Let me know what you think about the math. You know, give me an idea. Wow. That's amazing. But here, I do just want to show you this one more time. So this is just how many near-Earth objects there are. I think it's like over 1,500. Um, so I don't know exactly how many objects you need to have to consider it an asteroid belt. I mean, I would imagine that our area is going to be less dense than the asteroid belt and the Oort cloud, but I mean, I don't know. I still think that we should be demoted to a dwarf planet if Pluto is going to be for this very reason. Let me know what you think about that. Let me know if I'm just being facetious old man and I'm just fighting over Pluto because I remember it being a planet when I was a kid. I don't know. That is odd that Pluto is the one. That's another interesting thing. All the other planets are like on the exact same plane essentially. And then you got Pluto. I'm just gonna cross through Neptune's orbit. I'm just gonna be all inclined by like 15 degrees. Pluto really does do her own thing. Alright. Do 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 do. HO3, really? That's what they named it. Wonder how Earth's doing. Now that Pluto got its revenge, now you're just a cloudy Venus. Now what? Now what, Earth? Alright, I'm going to get out of here, guys. I hope you had a lot of fun today learning with me. Going to be doing this again every single Tuesday. So come on, hang out. And like I said, like, subscribe, share this with a friend and someone that you know that likes outer space. Share it with a flat earther if you're unfortunate enough to know one. Alright, take care and have a great day. Bye.